Using the recursion formula for gamma of x, so just a brief reminder, what is that? Gamma of x plus 1 is x times gamma of x. Determine the value of c so that gamma of 19 quarters is c times gamma of negative 1 quarter. Okay, so what can we do? Well, we've got our recursion formula. And we want to relate gamma of 19 quarters down to gamma of negative 1 quarter. Well, really, we're told to use this, so maybe we can write 19 quarters as something plus 1. Right? It'll be 15 quarters plus 1. And so what does our formula tell us? Well, you can write it this as 15 quarters times gamma of 15 quarters. And that's not what we're looking for. We want gamma of negative 1 quarter, but suppose we do it again. Okay. 15 quarters is just 11 quarters plus 1. So now our recursion formula allows us to rewrite this as 11 quarters, gamma of 11 quarters. And we do it again. And hopefully, as we continue on, we can get down to what we need. You see, we're getting smaller. Maybe we're actually going to hit negative 1 quarter eventually. So now we can write this as 7 quarters, gamma of 7 quarters. So 15 over 4, 11 over 4, 7 over 4. 7 over 4 is just 3 quarters plus 1. So again, the recursion formula comes in and says, well, you can rewrite gamma of 7 quarters as 3 quarters gamma of 3 quarters. And now we're at the last step, because if we notice, 3 quarters is 1 more than our goal of negative 1 quarter. So 15 quarters times 11 quarters times 7 quarters times 3 quarters times, and now we can bring out negative a quarter, gamma of negative 1 quarter. And all of this came from gamma of 19 quarters. So this is going to be our C value. Okay. So what can we do? Well, 4 times 4, I've got 5 to the 4 on the bottom. 4 times 4 times 4 times 4 times 4. 2 of those 4s are 16, so we get 16 times 16 times 4. 16 times 16 is 256. And we can multiply out by hand. 4, carry the 2. Okay. So the bottom here, the denominator, is going to be 1024. And multiplying all those 4s together. And then what have we got? Well, it'll be negative, thanks to the negative 1. Okay, 15 times 11 is 165. 7 and 3 is 21. So we're almost done. We'll just do a little bit of multiplication by hand. Okay. 2 times 5, 10, carry the 1. 13, carry the 1. 3. So 3, 4, 6, 5. And that gives us the value of C. Negative 3,465 over 1,024. Okay, so a little north of negative 3. Well, actually, I guess south of negative 3. But there's our precise value of C, and it came about just from repeatedly applying this recursion, taking the value that we wanted, writing it as something else plus 1, over and over again, applying our recursion until we got down to the negative 1/4. This wouldn't have worked if 19 quarters and negative 1/4 weren't an integer distance apart. Okay? One of them is 5 more than the other. Okay? So that's how this worked. And then it was just calculation, admittedly calculation by hand, but not too bad to do by hand, to actually recover our value of c.